what you're looking at here is a top-down bird's eye view of a Ford E450 Cutaway, which is the same platform that a Microbird G5 Type A school bus would be based on. This is our fuel system as it would be integrated on that vehicle, and it's actually fairly simple. We've essentially removed the gasoline fuel system and replaced it with a propane fuel system. So starting with the fuel fill nozzle up at the top, which is in the same location as the gasoline or diesel fuel fill nozzle, we flow fuel into the fuel tanks, which sit in the same location as the gasoline tank. We route our fuel lines along the same OEM routing as the gasoline fuel lines, but these are made out of stainless steel. And then we bring the fuel to the engine with our own dedicated propane fuel rail and injectors. And then we recalibrate the PCM of the vehicle so that the engine knows it's running on propane instead of gasoline. There's some different configurations and needs. We also have here an example of what a typical propane autogas refueling station would look like. It's very similar to what you'd expect on a gasoline or a diesel pump, with the exception of the fuel fill nozzle. This actually needs to be threaded onto the fuel fill port on the vehicle, so it creates a positive connection, which helps enable the fact that there's no spilling that would happen with the fuel. So once this cabinet is engaged, I couldn't pull this trigger and spray propane everywhere like you can with gasoline or diesel. The positive effect of that is that there's really no EPA, there aren't as many EPA and government regulations around the fueling stations because of that. There's really no way to spill the fuel. But you'll fill it about 8 to 10 gallons per minute, just like you do with gasoline or diesel. You can even engage a little trigger here and walk away while it fuels and get it about, as soon as the vehicle is full, it disengages on its own. And it's very simple, very similar to gasoline or diesel.
So here we are, we're at our clean room environment. As I mentioned before, this is where we process all of our fuel-related systems and vapor-related products. And the reason for that's pretty obvious, that fuels need to be kept clean and the products that deliver them, and so on and so on, right? So we've taken the ability to create this environment for these products, and it does a couple things for us. It actually creates the mindset to our operations and our operators that it's very important that we keep these products clean. And it also helps us from a testing and processing standpoint that the equipment itself is better regulated under these conditions with the clean environment. There's a temperature and humidity control environment here that helps us with that, maintaining these type of temperatures and what have you, keep the processes and testing very consistent, okay? So if you back up here a little bit, you'll see the fuel pump station. This is the final product, as you can see here. It's been successful, and do we know why it's been successfully passed? Because it has what? It has barcode labels, right? It had to get that by doing a few things. The operator had to follow through the IT system that actually walked it through, and it was verifying things along the way. And the only way you get that is you can't get around that circuit if you finalize every one of those cues, right? So that's the way we gauge ourselves here, right? In a nutshell here, you basically have the service pump station here. We treat our service items as we would any production product. In case that we have to build a service pump, which would be very few of those, we actually build it with the same type of criteria. Having a fixture, having component parts clearly marked and labeled. We use the same IT traceability system to guide us through that process. We reel this over and connect to it, right? And build the same product. Even as simple as building and cutting hoses here. We talk about all these complex assemblies. We know we can build a great fuel rail. We know we can build good and capable pumps. But all it takes is someone to cut a hose too short or too long, and this is what you'll get inside that tank, and everything's for naught, okay? So as simple as this could bring down the system. Okay, it's a starvation issue for the pumps. And the way we control that and decided to do so is that we're not going to measure every single hose. People make mistakes. We don't want people measuring things and looking at rulers and tape measures. So we basically developed a simple system saying, I'm cutting hose number 8. I place this little gauge to hose number 8. I feed the hose into a bump stop. I hit the lever. I've got a cut hose. I put the hose in the bin and I'm done. I know that every single time it's going to be within my tolerance. I know it's going to meet the needs of the system. And I know that I'm not going to allow this to go wrong. Okay? So those are simple controls we have in place there.
All right, welcome everybody. I'm going to take you through the tank assembly, engine assembly. We want to make sure that when a tank leaves here, it's built properly. The fuel sender, we check it in 2 different positions because it travels to measure the amount of fuel in the tank. So we check it in the level position and a slanted position to mimic an empty tank. So when the tanks progress this way, when they get this far, then the assembly's been done. And we know that it functions properly because we've checked the fuel sender, the pump, all the fittings are on, we've scanned it, it's got the right parts. So the last thing that we check, and very important, is the leak check. Unlike our competitors perhaps, or other people that do leak checking, who may dunk the tank in a vat of water looking for bubbles, or spray Snoop or soapy water on it looking for bubbles, that's too operator dependent. We don't rely on that. What we do is we pressurize the tank using a hydrogen-nitrogen mix. We pressurize it to 300 psi and it'll drop into this vessel. The lid will close and then we're measuring a leak rate. It's pressurized, so any leak rate in that chamber will be measured, and it's a very stringent measurement. It's like 1.5 parts per million. Our engine line, same type of airproofing traceability system where we scan the order and all subsequent parts. The engine's got more options than the tanks actually, so we do a lot of scanning over there to make sure we're putting the right parts on.